Today I'm going to put both a Bluetooth and an auxiliary input into an old vintage Yorx FM stereo clock radio. So this has got two speakers, two amplifiers, a nice vacuum fluorescent display. So I'm going to put auxiliary and Bluetooth, but first I have to fix the problem because after it warmed up a bit, well, the display doesn't look quite as nice as it looked when I previewed this in the previous video. Check it out. I was going to put a Bluetooth board in this old vintage clock radio that I picked up down at the second-hand store for $2. When I plugged it in, the display was kind of bright, but as it's been running for a bit here, I've noticed that the display is dimming out, so maybe there's a capacitor that's starting to go bad in the power supply on this. I think we'll take a look at that before I put this little Bluetooth board in there and turn this into a AM FM stereo with Bluetooth. So let's pop the top off this thing and see if I can figure out why that display is getting weak. And I hope it's not the display tube, although an hour ago it was brighter and it's gotten dimmer in the past hour. Like right now, if I turn it down to the dim setting, I can't even read it. But when I first plugged this thing in, it was much brighter. So I don't think we have a display tube problem. Although I do have an identical unit that the display tube did go bad on. And it had no emission whatsoever. I put a new tube in that and it's bright as anything. But hopefully the tube in this one's okay and it's just a power problem, voltage problem. Made in Hong Kong. Of course, this would have been made back in the day when Hong Kong was a British colony before it reverted back to mainland China. Because of course the Brits had basically colonized the city of Hong Kong. When the terms were up, it reverted back. But this was made back in the day when Hong Kong was still Hong Kong. I think I've got all the screws out of this. They put some glue on it. Interesting. In addition to putting the screws in, they put some contact cement around the outside, probably to stop vibrations. See, you wouldn't see that these days. See that? They put a little bead of contact cement, and I would imagine that was, again on the front here as well, I would imagine that was to stop vibrations from the speakers so the cabinet wouldn't vibrate. The fact that the display is brighter on the left side than the right kind of says capacitor problem, because of course as the display is multiplexed and as it scans across the tube, the voltage may be dropping if one of the capacitors is weak, because of course the capacitor is going to charge at the start of the cycle. We don't know what the refresh rate on this is, but it's going to start every time the voltage is rectified by the rectifier. The voltage is going to go up, and if the capacitor is not holding enough of a charge, the voltage could be dropping as the display scan takes place. So we got dimmer digits on the right side. There's one cap in the top here. This one here is the one that I would likely suspect as being problematic for. I hear the radio's going here. How come? I must have hit the snooze button or the sleep button on it and started the radio up. Anyway, I would suspect this one, so we're going to check this one out first. As you can see, this is what this is supposed to look like when it hasn't been hacked like my last one, where I had to put a different display in. So this one's nice and neat, and it looks like it's never been opened. The paint seals are still intact to hold the clock in place. Neat thing about this particular type of radio is that the clock was a completely separate module. lot of them, the clock module and everything was all integrated into the actual radio. Well, this one here is completely separate. You know, get your rectifier here for the radio. The transformer is connected. It's got 2 different windings. The yellow windings, I believe, are for the filaments. So it's got AC to the filaments. And then you've got the green, I think it's the green and the 2 red wires. One of them is a center tap. And the other one's a separate transformer, separate winding. But one's going to be for the radio, I think. And because I don't see any wires from the transformer that go to the radio. So this powers the radio up. So we'll just remove this display. Probably should unplug it when I do this. Probably should, yeah, there we go. Now it's unplugged, so I don't have to worry about shorting anything else out. I think there's one more screw right there. Notice these are metal screws as well. They actually have, well, this one was a plastic screw. This one went into plastic, but these 2 actually went into metal studs. So the capacitor, I think it's probably the issue is this one right here. So I'm going to change that. As I suspected, the 2 yellow wires, they are actually a separate winding for the filament. As you can see where they connect here and here, and they go directly to the filament winding. So one on that pin, and the other one goes across the front and connects to that one. And those are going to be for the filaments that you can see running across the front of the tube. There's 3 of them here. I don't know if they show up on camera or not, but there are 3 filaments that run across. You can see them right here. They are the direct heated cathode. So because this is a vacuum tube, right? A vacuum fluorescent display is essentially a triode. You've got your filament, which is the direct heated cathode, and then there's a screen behind there, and then there's the actual segment, each of the segments. There's 7 segments. And typically how these displays operate, although they don't have to, there's some displays are direct driven, others are multiplexed. Now this particular tube is a direct drive tube. We can tell that because if we look down at the grid, which is what's right in front of the segments, you'll see the middle one with the full colon on it. It is the only one that actually has a wire protruding down to it that's connected to the outside. So all those grids are all connected together. But in a multiplex tube, each grid would have its own separate lead to the outside world so that they could be individually switched. I'll explain how a multiplex tube works here. Typically, how these are connected is all the segments are connected in parallel. So you'd have all the top segments all connected together, all the A segments connected together, all the B segments, etc. All the 7 segments are all connected together. That way, they can control and multiplex the display so that only 1 digit shows at a time. And they do that by turning on and off the screen. So they can apply a negative voltage to the screen, and that will repel the electrons from the direct heated cathode to turn that digit off. So if they applied a positive voltage to the 2 segments, it would produce a 1. When they want the 1 to show up on, say, this digit here, they would apply a positive voltage to the screen, whereas the rest of the screens would all have a negative voltage, and that would attract electrons towards the digit that the screen has gone positive on, or the grid, which will attract the electrons through the grid to light up the anode, which is behind it. The other anodes, they're all positive as well, but because their screen is negative, the screen or the grid will stop the electrons from reaching the anode. So then they can control each one individually without having to have a separate wire for each one of these connections. Now this particular display has a total of 30 connections. On these clock displays it's kind of unique because the A and D segments on both the tens of hours and the tens of minutes are actually connected internally. So 26 for the digits, the AM and the PM is 28, the colon is 29, and the dot down in the bottom right corner, which indicates if the alarm is active or not, that's the 30 direct connections. A display that was a fully multiplex and only multiplex display would have 7 segments plus each screen. So it would have 7 and then 8, 9, 10, 11, 12, 13. 13 connections was all that would be needed, plus the 2 filaments. So a total of 15 pins is all that would be needed for a fully multiplex display. But I know that this one here is a direct display because I've already rewired one of these display panels before, and each one of these actually has a discrete output. Plus, if you look at the chip pinout, you'll find that this pinout can drive directly. It doesn't have to drive as a multiplex. This is a direct drive tube. Now, why is this important? A direct drive tube over a multiplex tube? Well, the multiplex tubes, due to the switching of them, generally tend to cause more interference to AM radio. So a direct drive tube is a far better choice for a clock radio when you've got an AM antenna that's only sitting a few inches away. So here's the old capacitor that's out here. Let's just take a look at the readings. We're going to look at this capacitor. We'll look at it on the ESR meter as well as on the capacitor meter. We'll just see what it looks like. See, it's pretty old. It's 47 microfarad, 35 volts, so pretty standard, common cap. But let's take a look at the ESR on this thing, and we'll see that the ESR looks to be through the roof. Well, 1.3. So a 47 microfarad at 35 volts should be like 0.68. We'll check the capacitance of this thing. Capacitance wise, measuring okay. We're going to change it anyway and see if that'll improve the display brightness. It might be that I got a radio that the display is weak on. Hopefully not, because when I first tested this thing before picking it up for $2, it was nice and bright. So I was excited that I got one with a good display, but after it's been running here for a few minutes, it's getting dim. Still not very bright. Looking at the layout for the chip, we've got a common source output here off of pin number 23, which goes to drive the display. Now looking at the application, normally they would have a transistor in place here that you would use to pull up to VSS through your brightness control, but in this particular design it doesn't have it. So what I'm going to do is I'm going to insert my own power source. I've cut the trace coming out of the chip going up to the display. Cut it right here. I'm going to apply my own bias to the actual tube itself. This is to bias the screens, because I say this particular tube is actually a direct drive tube, so all the screens are connected together. It doesn't have separate screens like a multiplex tube would. You can see what looks like separate screens here. Like each digit has what looks to be an isolated screen, but they're all connected together internally. So if I connect this and take it to the power source to bring the voltage up a little higher on the screen, I'm just going to take it right to the resistor here. We should increase the brightness and still have brightness control with the switch, but I should be able to get the brightness up higher than it was. So let's just take a look at that. Yes, it's definitely brighter, and I still have control. If I turn the brightness control down, I know it's awful bright in here with all the lights and stuff, but this is still, it's fairly bright. Might be that the tube is starting to get a bit weak, but that certainly is brighter than it was before when I was just relying on the source from the actual chip. Now I've used a resistor here. I've used a, what did I use? About a 56 or 5.6K resistor. Let's just see what voltage we've got going to the display here. At about 8 volts. So if I increase that display, that screen voltage, I should be able to get this brightness up. We'll try a lower value resistor, say maybe take it down to a 1K. Jumper the resistor itself completely, and you'll see the brightness will go even higher on the display. And I still have control. So I actually don't even need a resistor in there at all. I can put a jumper wire in place of that. I think I'll do that. That way I can get the maximum display brightness that this display, which is obviously starting to get a bit tired, is capable of displaying. So let me just go get a piece of wire. We'll just wire that up to give me maximum power to the display. As you can see, it's nice and bright now, and the dim control works. I think probably what happened on this, I'll try to explain the how this one works. This was a direct drive display. At first, when I looked at it, I thought it has separate screens. Looks like separate screens, but they're actually not. All these screens here are connected together, and they're all connected to, I forget what pin it was. I looked at it here, but it's the one that's connected here. They're all connected to this pin here. It comes through here, and normally it went down to the current source off the chip. I think the reason why the display was dimming out on this is because the tube itself is starting to get a bit weak, and it's drawing a little bit more current. And what would happen is once the thing had run for a while, it was overloading the chip, and the voltage was starting to drop, because unsourced or when the chip is not connected to the grid screen of the tube, the voltage on that pin of the chip goes up to full 24 volts, which is the supply voltage for the chip. But as soon as I connected the screen, it would drop right down to about 9 volts, and it would cause the display to dim out. As you can see, the dimmer control still works on here, so I don't have to worry about that. Looking at the chip here, if you look at the pin out, the output common source, they've got it going here into a transistor which is controlled through a 10K pot and pulled up to VSS. And the display is actually connected to this, the grid on the display is actually connected to this pin on this particular tube. But what's interesting about this design is if we look at the pin out, let's study the pin out of this chip. So this is the National Semiconductor MM5316. It's a digital alarm clock chip. It's direct drive, not multiplexed, and it can be set for 12 or 24-hour mode. But what we're going to notice on this one is this, see, 12 or 24-hour display format. But what we're going to notice on here, and this is what you can use this for. If we read the description, it's a monolithic metal oxide semiconductor integrated circuit utilizing P-channel low threshold enhancement mode and ion implanted depletion mode devices. So it'll switch the high voltage required for the fluorescent display. It says the circuit interfaces directly with 7-segment fluorescent tubes and requires only a single power supply. It can operate on 50 or 60 hertz, and it can be either 12 or 24-hour mode. Outputs consist of display drivers, sleep, timed output, and alarm enabled, power failure indication, and so forth. It'll operate between 8 and 29 volts. Does not require a regulated supply. So this can also be used in an automotive clock as well, and that's one of the applications here because it can run off of 12 volts. It's quite a versatile chip. If we look at the block diagram, you'll notice that it has, well, it's basically a 3, we'll call it a 3.5 digit display. Because as you'll notice, you've got your AM output, your PM output to turn on and off, to turn on the AM and PM indicators. But you see here it's got the 10 hours B and C, which makes up for 10, 11, and 12, the B and C segments. But it doesn't have segment controls for the rest of the digits for the tens of hours. It has your 7 segments for your hours. It actually has 6 segments for the tens of minutes because you notice that the A and D are on the same pin. And it has the minutes output. Minutes output here and over here. Common source output, that's to control the brightness. And it's got your snooze in, alarm out, alarm off input, sleep output, your supply voltage, VSS, VDD is your ground, sleep display in, alarm display in, seconds display in. If you bring these pins high, it'll display seconds. Slow set in, fast set in, 50, 60 hertz in, that's your input because this is line synchronized, so it counts the input from the power coming in, which would make it tough to work in a car where it's running off DC. You would actually have to have a separate oscillator to supply the 50 and 60 hertz, and car units do that. They have a crystal oscillator and a countdown timer, which will generate the 60 hertz or 50 hertz input, depending on whether it's selected. The blanking input, 12 and 24 hour select. It's got a 1 hertz output and a PM output. So the 1 hertz output normally would provide a pulse, turning on and off, like for making the colon in the middle of the display flash. Taking a look at the block diagram, here's where things get interesting. You see these 4 pins, 38, 40, 1, and 2. The 1 hertz output, the PM, the AM, and the B and C segment. It says to tens of hours digit. And you're wondering, what are they doing here? Well, the tens of hours is going to display a 1 or nothing in 12-hour mode. But in 24-hour mode, it needs to be able to display a 0, a 1, and a 2. And here's how they've done it on this design. If you're wiring this up for a 12-hour display, and you've got your 4 display tubes, and in this case, it's a 4-digit display tube, but with 4 individual tubes, you would use a couple of the segments, like for AM or PM. You'd use the top or the bottom for one for AM and one for PM if you wanted to have the 2 indicators. And you'd use the B and C connector, B and C going to form the 1. And that's all that's going to light up. Or if you didn't want AM or PM, you could wire just one of them for an AM indicator or one for a PM indicator. But there's no connection on the A, what is it here, A, B, C. So A and D and G is no connection. And it will only display 12-hour. But if someone wanted to configure this for 24 hours, instead of wiring that digit like this, they would add this additional circuitry. The B and C, shown here, will still go to feed the C directly, but the B is fed through a diode to light up the B. From the 1 hertz output, so when the clock is configured for 24 hours operation, the colon does not flash. The 1 hertz output is fed through a diode to also light up the B segment, and it lights up the A segment directly. The 1 hertz signal also is fed directly over to these two segments. So that's the D and the E. The F connection is fed from the AM output, and the G segment is fed from the PM. That way, depending on the voltage applied, if you apply voltage to the 1 hertz, you will light up these two, as well as so you'll light up the A and the B and the D and the E segments from that 1 hertz signal, which would be pulled high. You also pull high the B and the C, which will, of course, light up the C directly. And the B has already been biased on because it's going to get voltage either way through both diodes. And you turn on the AM indicator. So you would turn on the 1 hertz, the AM, and the B and C to display the digit 0. To display the digit 1, just the B and C would be lit by itself, because that would feed down through, go through the diode to light up the B and light up the C directly. And to display the digit 2, you would apply power to the 1 hertz, which would light up these segments here, the top. So the A and the B would light up. The diode would block the C from lighting up, so it's going to light up the A and the B. It would also come down this way, light up the C and the D, and you also want to light up the G, so you'd apply power to the PM. And that would give you the number 2. The AM indicator would be off, as well as the B and C indicator would display the 2. So with those 4 inputs, you could display a 0, a 1, and a 2 for 24-hour operation. But this is something on this particular design, using this chip, that has to be determined when the clock was developed. Are you going to wire this to display the time in 24-hour mode, or are you going to wire this to display the time in 12-hour mode? And if you want to change it, you have to add the 2 diodes and connect up the 1 hertz. Now, as I say, on this particular display tube that I've got, the 1 hertz is actually feeding the colon on this display. The reason the AM is flashing is that's indicating there's a power failure. But if I set the time on this, you'll notice that the AM indicator now stops flashing, but the colon still flashes. That's on the 1 hertz output. But in 24-hour mode, that 1 hertz output is not available. It's being used to drive some of the segments on the tens of hours digit. So that's the operation of this particular chip. It was a very common, very popular chip. So now that I've got this display working properly, I'm going to put the clock back in here, and we're going to work on putting the Bluetooth board into this radio. Now that it's back in its cabinet, you can appreciate how bright it is. I can now put a blue filter in front of here, make it a nice royal blue, and it won't be too bright. But right now it's really quite bright compared to what it was before. Thinking back, that other display in the other clock that was very, very dim, it was probably the same thing. It was probably the display was loading down the chip, and the output from the chip was dropping, because this particular design doesn't use an external transistor to pull the voltage up like it shows on the schematic here. Right? On the schematic, it's showing that they're using an external transistor to control the brightness. And on this particular design, there is no transistor here. It's just the output from the chip is fed directly to the screen or the grid on the display with no external transistor. So that's probably why the display was dim on this, and why it dimmed down after it was running for a bit, is because the chip couldn't pass enough current and the voltage was dropping to the screen. The other tube that I've got, that I took out of the other identical clock when I replaced it, also probably is, well, could be okay for that matter, because The new tube that I put in wasn't connected to the chip. It was a different tube that I wired directly to power, like this one now is. This one's wired directly to power. As you can see, the output is now fantastic. It's bright as anything. It's overloading the camera. It's so bright. Anyway, that's good news. So now, let's get on with the mod to put a Bluetooth receiver inside this almost pristine Yorx Clock radio that goes back to, I'm going to guess this goes back to probably the late 70s. I don't know exactly when this one was made, but it was a while back. Late 70s, I'm going to guess, because that seemed to be when all the vacuum fluorescent displays were around, was later 70s into the early 80s. And then everything kind of, by the mid 80s, the VFD display had fallen out of favor because LEDs, the price had dropped on LEDs, so most stuff had gone to LED displays. But this one certainly is unique and a collector's piece just because it's got your multiplex stereo, which most don't have. Okay, first things first, let's make the radio sound proper, because right now all the controls are dirty. Observe. So we'll get some contact cleaner and we'll clean those controls up first. That's one control done. We got to get into the other one to get the other one in the back here. A little harder to reach, but we'll get in there. Really making a mess in there, aren't I? Got the tone control too, though. I'll tune this down to the... I can put that on my test stuff. We get the AM/FM switch as well. To give you guys how pristine this unit is, it still has protective plastic film protecting the brushed aluminum from damage. That gives you an idea how good the condition this is. I think it may have been removed from this here. There's a little mark here, a little red crayon or something on here that somebody's marked it. But other than that, this unit here isn't. I thought that was a scratch first, but it's actually just the plastic. This is in really good shape, so I want to try and keep this in pristine condition. As much as I didn't want to have to take the whole radio out, I think the only way to get at that switch accessibly is to actually pull the whole chassis out, which is nice because the controls are mounted on a plastic bracket, which is all part of the radio. So I think there's 3 screws in the back here and 2 more in the top, and this whole unit should lift out, and then I'll have accessibility to the wiring on the switch. Because the way it's located in the radio right now, it's really tough to try and see what they've done. So let me get the chassis out, and then I should be able to rewire the switch and provide myself with an auxiliary input for the FM mono position. Look at this. The screws are metal screws. I gotta like the quality of this thing. I mean, I don't know what this radio cost when it was new. It was probably like 150 bucks, because this would not have been a cheap clock radio back in the day. It would have been fairly expensive, being FM stereo and all, because say the run-of-the-mill ones were not. This is a real deluxe radio. And the radio on this thing is actually pretty hot. The tuner on these is actually pretty good. I'll show it off a little bit later. But just with the built-in bar antenna, it has really good reception. And check this out. This is something you did not see very often on clock radios, is it has external ground and antenna for FM. The built-in antenna, which is just a piece of wire that's wrapped around the AC line cord. Like most radios, they use just a piece of wire to inductively pick up the signals, and the AC cord operates as your FM antenna. This one here, you can actually disconnect the internal antenna and connect an external. How cool is that? I mean, that's something that was, found on home tuners, but not so much on portable radios. This should, I think I've got the screws out now. This should lift the whole chassis out. Oh, there's one more in the bottom that holds this together. I think this is the last one. There we go. So say the radio lifts out as one chassis. It's got a dial cord and everything. I think there was a light in here at one point too, and it's probably burned out. Yes, there's the light here. I can fix that while I'm at it. My last one that I just put some LEDs in the top here. The last one I've got, but this one, since I've got the radio out, I'll take this opportunity to replace the burned out dial light. We can see here how the switch is wired. So here's the FM comes in on the green and the orange wire. Looks like it's jumpered here to the two terminals. And the green wire is going to be doing the same. I think back here, get my flashlight. And it's going to be jumpered. Yes, I can see the green wire is jumpered. So if I clip that jumper out here, that should break the one side. And if I clip this wire right here, that should break the other side from the mono position of the switch. And now we'll see whether it only works in stereo, or did I cut the wrong one. I may have to move the wire over, but let's just see what it does now. I'm going to power it up. Yeah, power on. Okay, that's AM, FM. That's FM stereo. And middle position is the FM mono position. Now I just have to figure out which input is which. I think this is the bridge. One of these is the bridge to bridge the two of them together. Maybe both of these are the bridge. Yeah, that's one input. I think these are the two bridge wires here. So if I take these out, I should have two separate inputs. There we go. Oh, you guys couldn't see that. Okay, so what I did is I cut, there was a bridge, what the gap for not paying attention, my camera moved, my tripod shifted. There was a bridge connection right here, and there was another one from the orange wire to bridge those two together, and the green wire was bridged here, and then these two here were connected up to both sides of the switch here, which provided the shunt. So basically this is left, that's left, and that's right. So that's all I need to do now is connect my input from my Bluetooth receiver to that wire and that one. We'll do it right at the switch itself, and then I can remount this thing, and we'll find a light to put in this thing. It's used an incandescent bulb, but I think probably I can upgrade this to an LED while I'm at it. So we'll just remove this LED, or this incandescent bulb. This is the reflector for it. The bulb is right there. And of course it's burned out completely. We'll find an LED to put in place of that, or even a couple of LEDs to put in place of that, and the appropriate resistor. For this, I generally use LEDs that I salvage from old bulbs, old light bulbs or flashlights. In this case, I've got one of these old cob lights. I probably paid $15 for this stupid thing when I bought it years ago, and I used it for a bit, but the light output on these things is just ridiculous. So I've been picking the LEDs off of it and using them for projects, just because they're nice white LEDs. I've got my LED all set up with its drop resistor. Solder it in place of the incandescent bulb. So there's my, actually I think I'm going to put a little bigger piece of heat shrink tubing on so that I can actually encapsulate the whole LED once I've done this. So let me grab a bigger diameter of heat shrink tubing. There we go. And I can put this right over top of the entire thing to encapsulate it like that once it's done. I've got heat shrink tubing on the other lead right now, so let's solder this in place. Just tin my wires. I can hear it now. Use a third hand. You can just hear the people screaming that I need to use one of those third hands. Yeah, don't need that. I'm old school. I learned to do this before they had those helping hands, those claws that some people like to use. It works. Okay, cut off that extra little lead there and drop it into the radio. Okay, now we'll just take our piece of heat shrink tubing, put it right over top to encapsulate both connections all the way down. Apply heat. Now I can just fish these wires back and insert the LED into the what used to be the old lamp holder. There. Ah, yes. Lights up the display quite nicely, actually. Excellent. Okay, now let's work on getting the Bluetooth board installed. These little Bluetooth boards require a 5-volt source, so I'm going to build a 5-volt regulator using a 7805 IC because the radio itself, the power supply in here, is a little more than 5 volts. It's more like about 15 volts. So So on 7805, I'm just going to hook it up. We'll hook it up to the unswitched power source so that the Bluetooth board is always powered up. That way, whenever the radio is turned on, if the switch is in the Bluetooth position, it will be ready to pair with the phone. I could power it up with the power switch and have the Bluetooth board off when the radio is off. Bluetooth is not something that you would normally be using on something like this if the radio is being used as a clock radio, because your phone's not going to be playing music all night to wake you up to your phone music. You're not going to be leaving the phone connected and streaming all night, but typically would be, if you want to listen to something off the phone or off a Bluetooth device, you'd switch it to Bluetooth and play it. So I could choose to either power it up with the manual switch or right off of the power supply and keep the unit powered up all the time. Either way, it's going to work because the Bluetooth board will always be ready to pair in that case. Okay, I've got my 7805 regulator set up to connect. We'll connect the positive terminal down to the positive output from the power supply, which is right here, to the red wire here. And the negative wire will connect it over to the negative terminal on the power supply, which is the black wire. And when I give this unit power, I should have 5 volts on the blue wire and ground on the white, just because I like to use my own color code scheme. And I didn't have any red and black wires handy, so no big deal. Power on, and we don't have 5 volts, we have 3.7. But that's okay because the Bluetooth board only needs 3.7 to 5 volts. Should have 5 volts there. I don't know why I'm not getting 5 volts on a 7805 regulator, because the power that's going into it is well over its input requirement. If we look at the power going in, hmm, 8 volts. Should be okay. It was measuring higher. I guess the regulator itself is putting a bit of a load on it, but it should be fine. 3 volts should be more than enough for this because it only needs 3.5 volts to operate. So we'll connect the Bluetooth board. We'll verify that the Bluetooth board works too before I connect it to the radio. So I'll connect up power to it and solder the power pins on. I'll plug it into my amplifier and we'll test using the 3.5 output. We'll test it to make sure that it's going to work with this power supply before I connect it to the amplifier and the radio. Got my Bluetooth board plugged in. Power it up and see whether this thing powers up or not. I may have to find a different power supply source for it if it doesn't have enough power. Okay, further checking. It's going to be the green as the return, I think, for this one, because there's 2 windings on this transformer. And I power it up now, and I get the Bluetooth power up message. So go into my Bluetooth settings, and there it is, XYBT. And I'm now connected. So if I go into my music player, there, that means it's going to work from the power supply in the radio. So now we can connect the audio output to my switch and I should get the sound through the speakers in the radio, and then I can button everything up. So let's do that. Okay, I'm now connecting the audio line to the switch to send my signal into the amplifier in the FM mono position. So I'm just disconnecting the old jumper wires that were used to switch the two audio sources to mono from the stereo decoder. It's quite simple how they did it. They just bridged on the middle side of the switch. They just bridged the two audio leads together. Now I can put this radio back together. That'll protect the wires from getting damaged because I've been moving things around here. I don't want to break any of them off. So we'll just reinstall the radio portion. Put a couple screws in it just so that it won't, I don't want to break any wires. Okay, I've got the ground wire connected here. I'm just going to tuck the board down here. I've rerouted the wires underneath the chassis because this unit here is going to go down underneath the radio and live below the chassis, just like that. So now when I power this unit up, we should hear it's in Bluetooth mode. When I power it up, we should hear the Bluetooth module boot up. Ah, there it is, Bluetooth module. Bluetooth module is now booted up, and it'll stay always running, even when the radio is off. Or even when the amplifier is off, the Bluetooth module will be running. If I go over to my phone, if I can get my phone to unlock, I seem to be having some trouble with the fingerprint scanner as of late. Go into my settings and into my Bluetooth settings, and I connect it, which is now connected. There we go. And if I start to play some music, there we go. Left channel, right channel. Cool. I now have a Bluetooth receiver in my classic Yorx stereo. To put the final touch on this before I put it together, I put some blue lighting gel in front of the clock. Remember, these ones originally had a piece of like 35mm film stuck in front, and there's a slot down here that this lighting gel can nicely fit behind. I can get it down there, and it'll also turn the display blue if I can get it in here. Now that looks cool. That's how it's gonna be when I'm done. Just gonna put it back together, and then we'll give it a full test. Well, here's the radio. Playing radio. If I want to play Bluetooth, I switch it over to Bluetooth, and I start my music playing. Well, you just heard it go through the phone, or the phone go through there, but and go back to AM or FM. FM. If I shut off the lights, you'll see that the dial is lighting up quite nicely. So let's kill some of the lights in here. There you go. Display illuminated by a single LED. FM stereo lights working. I've now got a radio with AM, Bluetooth, and FM. One other thing that I've added to this, that I added after the fact, I didn't record this, but I paralleled a 3.5mm auxiliary lead. So you remember the Bluetooth board, it had a 3.5mm stereo plug on it, as well as the terminals. So I just paralleled a 3.5mm plug with the internal Bluetooth board that I've added to the radio. So I have the choice. If I'm playing Bluetooth, it'll play through the Bluetooth board. If I want to plug an MP3 player or something that doesn't have Bluetooth into this and just use it as an amplifier, I can just plug it into this 3.5 millimeter plug. It's connected in parallel with the Bluetooth board. So now I've given myself a little more versatility. I've got 3.5 millimeter, and I've got Bluetooth, and I've got AM and FM stereo, all in my little classic, old, antique, basically now, Yorx Clock radio. Of course, to use the aux cord, I just switch it to the same input that I would use for Bluetooth, and I plug it into my MP3 player in this case, and it will play. So I can play this, or my Bluetooth from my phone. So I have both types. Now, if you didn't want to put a Bluetooth in, if you just wanted to put an auxiliary cord on this, you'd connect it at the same point on the switch here. But I've got the best of both worlds. I've got 3.5 millimeter stereo mini plug, and I've got my Bluetooth board. Now, I could have just done this. I could have just put the mini plug and plugged it into the Bluetooth board. I kind of thought about that after I went ahead and connected it up inside here, and I thought, you know what? I'm just going to leave the Bluetooth board inside the unit and just put an aux cord on as well. So I've got both, but I have the option. One cool thing about this particular model of clock radio that had a lot of features, or features that others did not have, besides having FM stereo, is the actual clock itself could display seconds. It actually has a seconds button on top. When you press it, it displays the minute and the seconds. So you can reset it by holding down the seconds in the fast, and that'll hold the seconds at 00. Or if you hold down the seconds with the slow button, it'll hold it where it is. So if I want to set the time exactly, for example, if I hold the time set button and I go fast, where's my fast button? Here we go, fast. So I want to set it to 12:34, and I want to set the seconds exactly to the time. I can now set it. It's now 12:34 and 37 seconds. So I can go until I get to 12:34 a.m. And here we go. We're getting to 12. I'll go to 12:35. 12:35, and then hold down seconds and hold down the fast. And then when it gets to exactly the right time, I release the fast. And now my seconds are now synchronized with my atomic clock, or in this case with my CRT clock, which is synchronized to GPS. So that is synchronized to the atomic clock. I can set my time exactly on here. So you can see my bright dimmer works. That display looks absolutely fantastic, especially with the blue gel on there. It looks fantastic. Radio lights up. I don't have an antenna on here, so even without an antenna, it's going to pull in all the local stations. And when I say I don't have an antenna, I don't even have the internal antenna connected. This thing is so sensitive. As you can see here, the antenna wire is not connected. AM on this is also really sensitive. My test transmitter. And AM sounds good.
Really change the way you look at it.
That sounds like DSL noise. That.
Over more of a mass, and you also want to make sure.
Cap space, and the Lakers.
Reason isn't enough, just knowing this.
All this noise you hear, that's, I believe, DSL.
She said it was impossible to choose just one, but at the top.
Back to my little test unit here. Anyway, that's my Yorx FM stereo AM clock radio, now with Bluetooth and an auxiliary plug. And of course, repair the clock because the display was getting dim. Hope you enjoyed this video. It's probably gone on too long. I spent half the day working on this silly radio, but hey, I've got a collector's piece now, and I say these ones here are actually getting quite rare. I've got two of them. I got one given to me that had a bad display, and I had got this one for, say, $2 down at the secondhand store. Couldn't pass that one up. We'll catch you in the next one. Bye for now.